So, hi everyone. I'm Markus Meixner, founder and CEO at ViewAR. Great that there is so much interest in this session and that you all came here. Today I will talk about how to use web technology for AR, and especially frameworks like JavaScript and the abilities of using those fastly moving forward technologies. So, I will start with a quick video of demonstrating what the ViewAR system is capable of and what we've been doing the past years. So here you see a product visualization visualizing shade of a specific awning size according to compass and GPS. You can also scan cargo loads or scan objects using depth cameras and compute volumes. So industrial applications. For an exhibition planning company, we did a system that visualizes different configurations of the exhibition space with different furnishings. And for Bang & Olufsen, we did an app visualizing the TVs and speakers, which won the Augie Award, World's Best AR App here at AWE. For Austrian Airlines, we did an application visualizing their airplane seats and guiding people through their features and abilities. And for an electricity company, we did a HoloLens application, as in walking through an industrial environment, being guided to a specific spot, there seeing IoT data visualized and performing a maintenance task. Also, we have the ability for product configurations. I'll dive deeper into this during the talk, assembling objects due to rule sets and so on. Also, virtual room creations. In the real estate field, we did a lot in regards to APIs towards CAD systems. So this is a Swiss construction project digitalizing 300 apartments from Revit data and all running in the browser. So this was a VR application running in the browser. The challenges that we currently see for AR tools is that the tools are too complicated and the technology is not accessible for, let's say, the right people. As in, the right people would be the ones who are at the companies who are in need of such an application and who know the business of that company and the business challenges. And we also see that almost every app is kind of developed from scratch. And this is a very time-consuming development that steals attention away from UX and content. So the way we structure our system in terms of the architecture is that we have a C++ core that is responsible for rendering and tracking, and we overlay that with an HTML layer for the UI. So this is where web technology comes in, allowing us to use frameworks like React and Angular to create application workflows using HTML and JavaScript. The core comes in 4 different versions. One of them is for iOS, Android, then we support the HoloLens, and the 4th one is a web environment. So there we have done a cross-compilation of our rendering engine, and we're using tracking systems like 8th Wall as an adapter to use, let's say, WebAR, WebXR to create WebXR applications, and they all use the same API. So those applications are connected to our ViewAR cloud, which is basically hosting not only the 3D content, also hosting the UI. So basically every app that you create, you save the UI to the cloud and access it from there. Also, we have a developer portal that lets us upload 3D content and manage the application. And those components shape the ViewAR system and provide a really good infrastructure and flexible infrastructure for creating applications, especially due to this decentralization of responsibilities. So the 3D designer can upload his content, the programmer can program his app, the styling guy can write CSS to style the application, and on load of the application, everything gets downloaded on demand and put together and then starts. So we go after an approach called templates. So we create templates for various industries, whether it's product visualization, remote assistance, indoor navigation, architectural cases, 3D scanning, reconstructions, basically everything that's around AR. And we then provide those templates via our app builder for non-developers. So here you'll see how to use our app builder, as in, let's say, selecting a template, then entering a so-called app ID, and then you can immediately start styling the application by changing logos and modifying backgrounds, and basically adapting it to your needs. I have to say this is not the main focus of the talk, so I will more dive into the coding approach, so the developer approach. I still wanted to present this as in to show you the complete picture. And yeah, obviously you can also customize CSS and make it look like you need it to. Add sample content. And once you have created this application, you start the ViewAR SDK app that can transform into whatever application you're currently creating. So this actually eliminates the need of all development environments, because you can create an app now. As we're in this speech, I will create an app and I will start it on the device, because actually the app logics are shifted to the cloud, and this is the approach that I will present. So now coming to the live demo. So I would actually just need one screen. Let me maybe switch this on. I think I have to do that on my computer. Sorry. There we go. So we have a so-called CLI in place, which is a command line interface. So it's a developer tool that you install. You just install it via npm. And then you have the ability of creating applications. So if I want to create an application, I will type mkdir, and I will create furniture live.demo. And once I've created this directory, I will switch into it, and then I will run the command viewer init. And this will bring up some kind of wizard. So it's asking me which application type I want to create, whether I want to create a plain JavaScript application, a React application, an Angular, or a sample project. I will pick sample project. And now I can choose from various templates that we provide with full source code access. So for example, let's approach the furniture one. So again, here I will enter an app ID, and I will say furniture live.demo. And I'll enter an app version. Let's stick to 1. And now the CLI will check out the source code of the application, of this template, and set up a local development environment. And this will purely be running using JavaScript and on my local device. I will also do a screen share of my device, just so you can see what's going on my iPad here. So let's see whether this went through. So as you can see, it's now checking out the sample project. It's installing the dependencies. It's initializing a Git repository and bundling the application for the very first time. Once it's bundled, it will be uploaded to the cloud. And then the application on startup will access this saved this saved application. So now it's uploading. Okay, so now I have various ways of starting the application. So I can right away use the ViewAR SDK app to try out the bundle that I've just created and run it on my local device, which I will now do in order to show you the feature set that we came up with for the furniture industry. So it would be furniture live.demo, and once I hit start, it's going to download the application code and give me the template as it comes with a fresh installation. So I will show you features like live view, as in I can film the environment and initialize the floor, and then I can add a virtual item. So let me pick this one here. So now it's downloading the model on demand. Once it's downloaded, it will use the caching abilities to serve that in the future. And now I have this object here, and I actually tapped twice. And I can also change color variations and try out different materials and see how it looks. Obviously, in terms of rendering and details, our engine is very strong, and our content preparation abilities are very good in terms of uploading and preparing 3D content. I also want to show you another feature, which is our so-called empty room feature. So basically what I will do now is I will kind of measure the surface that I'm on now. So let's say my room, as this speaking area starts here, and I'm doing a bit of a guess here, and saying I have this corner, and then I have this corner. And once I'm closing the room, it will ask me to define the height. And what I can do then is I can select doors and windows. So I can say I'm having a door here, and bringing in the audience, having a window to the audience. So let's say my audience window is here. And once I confirm, it will create a virtual representation of this room layout and place it in my environment. So this will ensure that I can actually place objects that wouldn't fit in the real space, and in order to kind of clean my room. And seems like we have a loading issue. Okay, I'm going to skip this one. But this was a part of the feature set that we provide for the furniture field. But now, when it comes to maintaining such code and such scenarios, there is a feature that I wanted to highlight, which is, or basically our development environment, which is started using an npm command, so I can run this application using npm run start. And now this application will open in the browser. This version on my desktop will not have capabilities for using the AR camera. It's a so-called mock-up environment that lets me simulate AR. Because how we see it is that as soon as you need to use your device and run around for an AR application in order to try it, you're using time, and this is a repetitive process that should be kind of simulated. So imagine I would use this application and I would click on live view. It would tell me, please film the floor to initialize tracking. And here in the lower corner, I can simulate that ARKit has found the tracking, and then I'll be forwarded to the next step. And here I can simulate doing what I can do with within the application, as in selecting an item, and for example, I can select it and then see the colors, and then I can switch to blue, and then I can open the shopping cart and see that I have which items I have in my scene in order to do a checkout and so on. Let's imagine these steps were now, in terms of, let's say, initializing tracking and opening the shopping cart and so on, was a bit of a journey. Obviously, not that much, but it will do the job for this presentation. So if I then look at the components in the source that we provide, you will see that I have a shopping cart item here with so-called GSX templates. So that's a very common approach for JavaScript development, to use display templates. And for example, here, as I see it in the browser, I have amount 1. And if I now decide to remove this part, or let's say I want to have another item and I would want to duplicate it, and I save this, my application will reload the current view, and we'll have the item still in place, and the amount and the additional fields are added. So the idea is that you don't, for every change, you don't need to restart and run through the whole process of the application. You can actually work way more efficient than having a build process, then copying it onto the device. And this is kind of a simulation interface that we're using here. So I want to more dive into our API features and how you actually communicate with our system. So in terms of tracking systems, we have meanwhile integrated 14 tracking systems from all kinds, whether it's CAD model tracking, whether it's for indoor navigation, whether it's for marker recognition. So basically our job is to provide this as a service to the developers to do the hard work, as in integrating the tracking systems and providing one generic layer. And as you can see, no matter, as you can see, no matter which tracking you're using, the commands in order to use this tracking and activate it and handle tracking status will always stay the same no matter which tracking you have. This gives you the power to try your single application with multiple tracking systems, identifying which one works best, and also you can stay on, let's say, on the cutting edge technology, because probably in half a year, the tracking you picked might not be the best one anymore, so you can easily switch. And so this is in terms of tracking and how you initialize tracking. In terms of how to access our repository, the commands are to fetch a model from our repository that provides an object, and you would then get a pose in front of the camera. So you would say get pose in front of viewing direction and with a distance, and you would then insert an instance with this distance. And this will return an instance object, which you can then use to whatever, delete, set properties, and so on. Touching the topic of properties, every item has the ability to have color options and configuration options. We call this properties. So, for example, this chair would have an option for fabric with 5 values and an option for wood with other values. And in order to change a material option, you would just trigger a single command saying set property values, fabric goes to option 4, and wood goes to dark. And then our engine handles the download of the resource, handles the material switch, even on multiple surfaces, and also comes with the ability of so-called configuration logics. So you can, in fact, define rule sets of saying these color options should only be available under those circumstances. And then our system will pick a version that works. So as this sample shows, the option 1 to 4 are coming with rules saying that option 1 is only valid if wood is light. And option 2 is also valid only when wood is light. So if in case wood is dark, switch to dark, our system would automatically revert option 1 or 2 and set the first one that would be valid. And it's way more complex, and then the abilities are way richer than I just showed. But this is the base principle. And for the case of the awnings that I've previously shown in the video, we have so-called parametric items. So we have created an algorithm that lets us mark and define parts of geometries that should be stretched and parts that shouldn't be stretched. So this gives us the ability to scale an awning to a centimeter size and not distorting the arms and not ruining the animations. This is like a really mathematical challenge that took us almost a year. And with this, you can obviously also define rules. So I've gone through a few features now of our so-called Furniture Live template, which is for product visualization. I will now show a quick video what we provide in terms of remote assistance. So we have a template called HelpR that works basically, as you might know from other remote assistance providers, to transfer a camera image from one device to another. But there's more to it, as in, so camera image streaming starts, and then you have a camera image transferred, and you might be able to see those red dots, which are feature points that let us identify the depth for a touch. So there's actually a coordinate system established on both sides. So the admin or the support agent can even press pause and mark something. Even with a high latency, the user will see the mark in place. And once those two marks are set, the call is ended. And so now, after the call is ended, there is a so-called review process started. So the support agent can now define and tag what he was assisting for. So this would be, let's say, the machine name, the device name, and you could tag what you have shown, and for each annotation that you did, whether it's with finger drawing or whether it's with an annotation symbol, you can define what you were actually supporting and assisting. And our system will then save this point cloud and this recognition pattern to the cloud, and then give you the ability to later on load it at a later stage. So this is in terms of knowledge management and keeping up a database that is continuously filled with new knowledge, bit by bit, in terms of the features. But in terms of, let's say, our platform, the power lies in that we provide this with source code access. So you can add your authentication, you can add your user flow, you might want to change those, the layout or the application flow, or connect to database, maybe to your SharePoint, maybe add a chat for file transfer, whatever. And you should not worry about the AR part, because the AR part is first already done, and second, the stuff that you have to do with AR is very narrowed to a few calls and interactions that I will now highlight. So we have a so-called call agent, a ViewAR call agent, which is an object that gets initiated with a so-called session ID and a username and a password. And once you initiated this object, you can join this session as a client. And once you have joined this session, you can then start a relocalization. So, or actually, yeah, let's say once you have done the session and once you have saved it, you can then do a relocalization. And I will show you how simple this relocalization with our system performs. So basically, you can use this with tracking systems like PlaceNode, with 6D AI, with Wikitude, as in activating a tracker. And once you save an annotation, you retrieve a map name, which is a string. And then you can also get the so-called scene state. So this is a method that gives you actually a JSON object of the scene representation. And then you can deactivate the tracker. And the next time you want to see this is you call a command called load tracking map with your map name. You activate the tracker, and then you tell the scene manager to set the scene state to what you have saved. And this will restore the scene. So the relocalizing on an object and restoring the scene is done with 3 lines of code. And that's why we say the AR part is actually pretty small in such application. The more work will go on the implementations and on connecting the APIs, putting it into your internal company structure, and maybe even having your, let's say, company internal people and web developers working on this. And that's wherefore we provide our help art template. In terms of depth sensing, I want to show a quick video of the Lufthansa application. Basically, in the cargo scenario, you have the tricky thing that obviously the airplane has a limited amount of space, but it has a round shape and gets thinner in the end. So every pallet has a unique proportion that is kind of the capacity mask, let's say, or limit. So first you need to check the capacity mask, and then you can start scanning this cargo pallet. And walking around the pallet will create a 3D model, and then we have 2 methods that you call. I will dive deeper into this later. So let me go through this. So yeah, basically once he was walking around, he can then capture screenshots, he can see what's out of bounds, and so on. But looking at the programming APIs that you would use for this. So first of all, this would work with 6 degrees, so 6D AI, as in using the camera image for the reconstruction, and this would work with the structure sensor. Also, it would work with the HoloLens and using its reconstruction abilities. And basically, to do a reconstruction, you trigger a tracker activation, you start a mesh scan, you stop a mesh scan, and you compute the volume. So those 4 lines of code are very powerful in the scenario I've shown. And as in 3D reconstruction and industrial environments. Addressing the topic of indoor navigation, we have created a template called GuideBot. I hope I'll have sound now.
Hi there, how can I help you?
I'm looking for a bed.
Which type of bed? Platform bed or a box spring bed?
Box spring bed.
Okay, please follow me.
So this character now guides around and identified the POI using chatbot APIs. So we have integrated Dialogflow, we have integrated Amazon Lex, SAP Conversational AI. All those chatbot interfaces are integrated in our system. And now it's going to introduce the item.
This is our top seller. Go ahead and give it a try.
And yeah, so this is a very powerful application where the work lies on the content, on adding all kind of abilities and content here. I want to show you how such a map is created as a quick instructional video. So how you create an app with our GuideBot template. By the way, this is using this tutorial is using PlaceNote, so a visual recognition system that works quite well. Actually, let's say the space is limited to a few hundred square meters. Currently, we're more shifting towards 6D AI, which brings in better performance in terms of size and relocalization. But we're also trying 3 or 4 other systems in parallel just to stay on track with the abilities on the market. So here you define the so-called waypoints. So the system basically consists out of a network of, let's say, streets or roads that the robot is able to fly and guide. And then you have those POIs. POI stands for point of interest. So you define where you have which destination. And then the system will look for the shortest path according to where you are. And that's all done automatically. And you can then insert a description for your item and save this to the cloud. Again, this will save the network of roads and POIs, plus the recognition pattern done by PlaceNote. So in order to load this, the application is rebooted, which will, let's say, eliminate all the tracking information. And you then select this map. You see an overview as you're the admin. And then you can choose whether you want to edit it or you want to navigate with it. And then you can film around, and the system will do a relocalization. And then you can let the robot appear and guide you around. So again, this is provided with full source code access, combined with our engine, just having a few API calls in the AR part. And you as a developer should then add the content, maybe vouchers, maybe recommendations, and all sorts of content that would fit within such an application. And these parts are, again, not AR related, and that's why we stand for not for using web technologies for AR. And yeah. In terms of the chatbot, just to show a few API calls. So we have a component called ViewAR Guide that obviously we activate the tracking and so on, and then we call a method called initGuide that gets our viewer API passed, and it has a bit of configuration, as in which language it should speak and which welcome message it should have, and then we can initialize this object. And in terms of speech interpretation, there is, you can easily define a callback method. So this is a very rudimentary sample of interpreting speech input, as in getting an input of the text and the language, and this method just checks whether the string name is contained. So if you would ask, what's your name, can you tell me your name, and whatsoever, and then it would say, my name is ViewAR Guide. Again, this is very rudimentary, and this should be connected to a chatbot API using the company's knowledge and business data. In terms of the graph controller, what we provide there is methods like find path between two paths, and then you can trigger a method called follow path with positions, and then the robot will interact automatically. It will wait for the user. If the user doesn't approach or doesn't come close enough, then it will hover and idle, and then if you come closer, it will continue walking, and all those things that summed up to be, let's say, yeah, almost 1.5, 2 years of work that is in the Guidebot template so far, that you don't have to do as a developer. And again, this is just, let's say, a brief look onto what we're providing with our platform and for the AR field. And yeah, this was it in terms of the live demos. You're more than welcome to pass by at our booth and see some things in action, and also get a demo of the Guidebot.